Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Sepang Mapotsami. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. Now, grade 12, in today's lesson, we are focusing on probability. And for this lesson, we are going to look at, or we're still focusing on the grade 11 revision. So we are on the second part of our grade 11 revision. Now, by the end of this lesson, you must be able to revise grade 11 probability. And for grade 11 probability, we are going to specifically identify dependent and independent events. And we are going to now apply the product rule where we are dealing with independent events. And our product rule is the probability of A and B is equal to the probability of event A multiplied by the probability of event B. We are also going to now revise the notion of tree diagrams, where we are saying we are going to work with the use of tree diagrams for probability of consecutive or simultaneous events which are not necessarily independent. This information comes from our CAPS document 2011, and it is also stipulated in our grade 12 ATP for 2025. Now, coming into this lesson, we must still work around the topic of probability that we started with in grade 11. We must remember the product rule for the independent event, which is probability of event A and B. It is equal to the probability of event A multiplied by the probability of event B. That is to say, the probability of event A and B occurring, it is equal to the probability of event A multiplied by the probability of event B if the two events are independent. And we are going to work with the use of Venn diagrams to solve the probability. So we need the knowledge on the Venn diagrams to solve the probability problems, and we are going to derive and apply the formula for any three events, A, B, and C in a sample space S. Right, now grade 12 below we have our baseline activity, and for this activity, grade 12, you are given 7 minutes to complete this activity, and your 7 minutes starts now. Welcome back, grade 12. Now, let us now focus our attention to the baseline activity. Now, in our baseline activity, we were told that a survey was done amongst a group of 75 learners to determine which sport they watch on television. They chose from athletics, netball, athletics with noted with a capital letter A, our netball a capital letter N, and our rugby with a capital letter R. And some of the information was collected as follows. 12 learners watch netball, rugby, and athletics. 25 learners watch rugby and athletics. 32 learners watch netball and athletics. 38 learners watch rugby. 5 learners watch only netball and rugby. And 9 learners watch netball only. 4 learners watch athletics only. Number A, we are required to determine the value of A, B, and B, C, and D. So we can see for this question, we're given a partially completed Venn diagram. So with this partially completed Venn diagram, we can see that A, our B, our C, and D, those are the parts of our Venn diagram that were not completed. Now, let us now focus our attention to number 1. So from our Venn diagram, to determine the value of A, this is what we are going to do. Now, we are going to remember that we're told that 12 learners watched netball, rugby, and athletics. So the 12 learners, it was for all three events. So the 12 learners was plotted nicely there in the middle. We were told that 25 learners watched rugby and athletics. So we're going to come back to the 25 learners watching rugby and athletics. So 25 learners are on rugby and athletics. So this is rugby, this is athletics. So for the whole of this intersection, those are 25 learners. And we are now told that 22 learners watch netball and athletics. So this side, the whole of this intersection, which is between N and A, netball and athletics, that intersection, we are having a total of 22. Then we are told that 38 learners watch rugby. So 38 learners watching rugby, it is the whole of R. So the whole of R, it was 38. Then we are told that 5 learners only watch netball and rugby, and the 5 learners only watch both netball and rugby, and 4 learners only watch athletics. Now, let us look at the value of A. The value of A, it is found on the intersection between netball and athletics, and we are told that the total for the netball and athletics only, which is the intersection between netball and athletics, it was how much? It was 22. They said 22 learners watch netball and athletics, but in these 22 learners, we still have the intersection of 12, where that 12 includes learners that are watching all of the 3 sports. So to get learners who are only watching the netball and athletics, we are going to say 22 subtracting the 12, because the 12 is already included in the 22. Right? Then we get our A is equals to 10. Right? Let us move on. Then to find the value of B, we're told that 25 learners watch rugby and athletics. So where rugby and athletics intersect, that is where we are having the 25 learners. But what do we see again? We can see that the total of that 25 also includes the intersection of all 3 sports, which is the 12. That includes all netball, rugby, and athletics. And what we are looking for now at the value of B, it is only this portion of space where we are focusing only on the rugby and athletics. So what are we supposed to do here? We are going to say from the total of 25, we are going to take out the 12 so that we remain with the B only, which is the one for rugby and athletics. So it's 25 minus 12, we get our value as 13. So that is what we're looking for there. We're looking for only rugby and athletics. And again, when you go back to this, you'll realize that when I add 12 and 13 must be giving me what? 25. Right, let's proceed. Right now, we're going to number C. Now, what are the C talks to? C, we are looking for the rugby only. Now, how do we get that value of C? Now, we're told that 38 learners watch rugby. What does it mean? It means 38 learners belong to all the event of rugby. So this one, it is all 38. So we can now see that C, we are looking for only the part that speaks to rugby only. So no intersections. So to find that value of C, we can see that 38 include all of the intersections. So to find C, we are going to take 38 for the whole, which is the total for the rugby, and we are going to subtract all of the intersections because C, it is not falling within or doesn't fall within our intersections. So we're going to take 38, subtracting 5, subtracting 12, subtracting 13 also. Then we get our C as 8. That will represent rugby only. Then let's proceed to our D. Now, what does the D speak to? The D speaks to the remaining. So these are the ones that are not doing what? They are not participating in any of the events. So we can now know, we know that our total events for the sample space, it was 75. So we'll take the 75, we'll subtract all of the events that we are having for netball, rugby, and athletics. Then the answer will remain with, it will represent the learners that are not watching any of the sport. So go to take 75, subtract the 9, subtract the 5, subtract the 12, subtract the 10, subtract the 4, subtract the 13, and subtract the 8. So we are taking the total and subtracting all of the events, and the remainder, it will be those that are not watching any of the sports. Then our D, it will become 14. So 14 learners are not watching any of our sports. Now, let us look at number B. Number B says, calculate the probability that a learner selected at random watches athletics or both the netball and the rugby. So what are we looking at? We are looking at a learner that is watching, probability of selecting a learner that watches athletics or that learner watches our netball and rugby. So that's what we're looking at. So the first thing that we're going to do here, we need to find the learners probability of learners watching athletics, and we're going to add it with the probability of learners watching both the athletics and the rugby. So what we're going to do now is the following. We are going to do the probability of athletics. So we're going to go to the athletics to say we want to know how many learners watch athletics. So we're going to now take the whole event of athletics. So it's going to be the 12 plus the 13 plus the 10 plus the 4. So all of those learners that are belonging to event A, we add all of them together. That will give us the probability of A, which is 39 over 75. And we are now going to look at the probability of learners watching both netball and rugby. Both netball and rugby is the intersection between netball and rugby, excluding the athletics. So it's going to be 5. So it's going to be 5 over 75. So it is the desired event, which is A over the total. And again, netball and rugby, which is 5 over the total. Then, to find that probability, we can say probability of A or the probability of N and R, which is A, athletics, or netball and rugby is equal to probability of athletics plus netball and rugby. Then we get our answer as 44 over 75, which is 0.59. These two decimal places. Now, let us now turn our attention to today's lesson. We must remember that our independent events are events that are two events that do not affect each other's outcome. What does it mean? That means the probability of selecting, let's say I have a bag of marbles here. I have maybe a red, green. Right. So these are the marbles that I am having. So that is to say, choosing two colored marbles from a bag with replacement does not affect the second outcome. What does it mean there? Let me just have more blue and a blue. So that is to say, if I take both red in the first event, what do I do again? I go and replace those marbles. After I've chosen them, it was going to be 2 over 6. Then after I chose them, I return them back to my bag. So because I'm replacing, that means the probability of now selecting the green marbles is still going to be 2 over 6. That is to say, because we have replaced the red one that we have taken out initially. So these are events with replacement. They don't affect the outcome of the next event from occurring. Then dependent events are events that when the first event A affects the outcome of the second event B. That is to say, when you choose 2 coins from a wallet without replacing the first coin, the first choice affects the second choice, and the coin in hand is no longer available for the second choice. That is to say, in my first event, let's say, for example, I have 2 coins. Then I take out 1 coin on the first event. Then on my second event, I will only remain with 1 coin. What do you see there? The first event, after I've taken in the first event, I had a probability of 1 over 2, which is how much? Which is 50%. Now, in the second event, I do not replace the coin that I've taken out. I proceed and choose on the second event. On my second event, I can now see that I only have 1 coin, which is the total. So it's going to be 1 over 1, which gives me a 100%. So what do we see there? So under dependent events, the first event affected the second event because the first event there's a 50% chance. Then on the second event, no longer 50% is now 100% chance. So those are the dependent events. And we are going to look at the two-way contingency table, which is a very effective way of representing data that is classified according to 2 different aspects simultaneously. Now, under dependent events, remember we are saying these are events whereby event A is affecting the outcome of the second event B. The dependent events occur when the outcome of one event changes the probability of the other event. That is to say, the example that we've used, we have mentioned that we had two coins. So in the first event, I want to maybe choose, let's say my coin, it was R1, and the other one was a two-rand coin. So in my first event, the probability of me selecting a two-rand coin is going to be 1 over 2 because I have two coins in this case, which is now 50%. Now, I take out maybe one of the coins. If I take out one of the coins, what you see now, on my second event, I do not replace or I don't place back the R1 back into the bag. Then what happens, or on my wallet, I remain with only the R2 coin. So the probability now of selecting that R2 coin is going to be 1 over the total is how many? It's 1. So it's going to be 100%. So what are we seeing here? We can see that the event A has affected the outcome of event B because the probability was 50%, the probability now has changed to 100%. Right, in most cases, these events they take place without replacement and we call this dependent events. And we are now saying when events are dependent, the product rule does not apply. On our independent events, this is events whereby two events that do not affect each other's outcome. We are now saying the two events are said to be independent if one event does not affect the probability of the other event from occurring. That is to say, to choose, like let's say for example, I have that red, green, green. Now, the probability of choosing two colored marbles. So let's say I just want to choose maybe a red and a green. So it's going to be 2. I want to choose 2 at the same time. So it's going to be 2 over 1, 2, 3, 4. Let's say it's just 2 over 4 in that case. Now, what you see under 2 over 4 there, we are seeing that this is going to be 50% probability. Now, in this case, we are saying under independent events, event A, we are going to replace the R, the red and the green one that I've taken out on my first event. When I place them back, I still have R distance to say the probability of me selecting 2 green marbles is still going to be 2 over 4, which is 50%. So the probability on the first event does not affect the probability of choosing 2 colored marbles on the second event. So the probability remains the same as we can see right there. Right. In most cases, we are saying these are the events that takes place with replacement, and these events are called independent events. Then we need to now understand that the product rule applies to the independent events. And remember, our product rule says the probability of event A and event B occurring will be equal to the probability of event A multiplied by the probability of event B. Right. So that is our product rule right there to say probability of A and B is equal to probability of A multiplied by the probability of B. Now let us look at the tree diagrams. Tree diagrams are constructed to show all the possible events, and mostly they illustrate the combinations of events. Tree diagrams are useful to represent all possible outcomes of 2 or more consecutive events. They can be used for dependent and independent events. And we need to understand that each branch shows a possible outcome and each branch shows the probability of an event. Now, let us look at a tree diagram. So how do we construct a tree diagram? When dealing with the tree diagrams, you always multiply along the branches and add the probabilities moving down the branches at the end. That is to say, the sum of all probabilities will always be equals to 1. And we need to understand that the probabilities on all branches of each split will add up to 1. And the final probabilities of all combined outcomes will also add up to 1. So those are the rules of dealing with a tree diagram. So we're going to apply these rules when we just deal with a tree diagram where we are working with 2 tosses of a coin. Now, the first event we are having the probability of getting a head or a tail is 0.5 and 0.5. And we can see if we add 0.5 and 0.5, we get 1. So each split, the split that you see here, it adds up to 1. Again, the probability of getting from a head to get a tail is still 0.5, 0.5. When we add them, we are still getting a 1. So each price split, it is giving us a 1. So this is what we say now. In the first event, we are going to say we have 0.5 probability of getting a head or a tail. Then on the second event, we can now look at head, tail, and tail, head, and tail, tail. Right. So now, we are now saying to you, remember, for probabilities, we multiply along the branches. So we're going to take this one and multiply by that one. So the first one is for H. The second one is for T. So it is the H multiplied by that T. So the H is this one. Then the third one, it's going to be the TH to get a tail on the first event and the head on the second event. So that is the third one. And the fourth one is going to be the tail and the tail, which is T and a T. Right. So if we add all of these probabilities together, they will add up to 1. Right. Now let us look at the example where we are constructing a T diagram. We are told that a bag containing of 4 red metal balls, 5 blue metal balls, and 3 green metal balls. A ball is chosen at random and not replaced, and then another ball is chosen at random again. So what are we looking at here? We are looking at our dependent events. Why? Because we are not replacing. So let us now construct the tree diagram to list all the possible events. Then we are going to work with the tree diagram to calculate the probability of selecting a blue metal ball in the first row, a red metal ball, then a green metal ball, and 2 metal balls of the same color. Right. Now, to construct a tree diagram, we are going to look at the following. The red, we told that we had 4 red marbles. We had 5 blue metal marbles. Then we had 3 metal marbles. So the total for all of these metal marbles is how much? It is 12. Now, we are going to work with this on 2 events. Now, for the first event, the probability of selecting a red marble, it is 4 over 12. So it's 4 for the red. So the first line talks to the red. It is 4 over the total, which is 12. The second one talks to the blue one, which is 5 over 12. So the 5 is for blue, and the total is 12. And the third line, we are now looking at the total for the green is 12 over 3 over 12. Now, on my second event, what am I going to have? So if I pick red on my first event, then I still have the red, the green, and the blue, and the green. Now, let us now proceed and say, remember, these events are without replacement. So if these events are without replacement, the first event is for selecting a red marble. What does it mean now? From the total of 4, I am now going to take out, if I take out the red marble, then what happens is the following. I take out the red and I don't replace it. So the red marbles will decrease to 3. So the total for the red now, they are no longer 4, they are 3. Then the total of all marbles in the blacks, it now reduces to 11. Why? Because we are not replacing. Then we can say the first event is for selecting a red marble. Then it's going to be 3. To say 1 red is taken out from the 4. Then the total again will change because we are not replacing that red marble again. So it's going to be 3 over 11. Then when you now see the second event of selecting a blue one, red, then a blue one, then it's going to be 5 because the blue is not selected here, over a total of 11. As we didn't replace the red one, then the green one is going to be 3 over 11. That is the first event. The second event speaks to the changes on the blue. So the first one, it was the changes on the red. Then the second one will be the changes on the blue. So what does it mean? It means now the red marbles are still 4. That's what we are now saying, because here we're checking the probability of selecting a blue marble first in the case. Right. So the probability of selecting a blue marble first is going to be now, from the blue, we are going to subtract 1, because that's what we're operating with here. So it's going to be 5 minus 1 are going to be 4. And remember now, if I take out one blue marble and I don't replace it, the total also will change to 11. The total changes to 11. The red, they go back to the total. Then the blue, we subtract 1 from the blue because here we are talking about selecting the blue first. And the green, we are now saying the green unchanged is 3 over the total of 11. Right. Then the last event, it is the probability of selecting the green marble first. When you talk about the green marble first, that means the green one here will be affected. So if I say we are dealing with the green now, it's going to be 3 minus 1. So we are going to say on the part of green, we are going to now say 3 minus 1, we're going to remain with a 2. And when I talk about the green, I don't replace it. The total now remains to be 11. And this one is going to be 11. This one is going to be 11. So you can see that in each event, only one will change. And if there's no replacement, it also changes the total. Right. Now, let us look at number 2. Number 2, it says, calculate the probability of selecting a blue metal in the first row. So if the blue metal is drawn first, what are we looking at? We are looking for those that deal with B first. Which ones are those? So it's BR, B again, and BG. So it's going to be probability of a blue and any, because we want to say when the blue metal is first drawn. So it's going to be B, probability of BR, BB, and BG. So all of those that start with a B. And we can now say the BR is going to be 5 over 12 multiplied by 4 over 11. Second one is going to be BB. It's going to be B. For the first B is going to be 5. The second B is going to be 4 over 11. Then BB is going to be 5 over 12 multiplied by 4 over 11. Then the third one, we're going to start from there again, because it's the B and the G. So this is for the B and the R. This is the B and the what? And the B. And this is the B and for the G. So this is B, which is 5 over 12 multiplied by the G, which is 3 over 11. Then we get the probability of S 5 over 12. Number B, use the T diagram to determine the probability of getting a red metal ball, then a green metal ball, it is drawn. So here we are looking at a red metal ball, then the green metal ball, it is drawn. So in this one, we are just looking for the red and the green. So it's the probability of R and G. So which one is that one? This is the one we are looking at. So it is for the one for the R. This is the R and the one for the G. So those are the two events I am going to multiply together. So that's going to be 4 over 12 multiplied by 3 over 11. Then the probability is going to be 1 over 11, which is 0.09. Then let's look at number C. Number C, calculate the probability of selecting the two metal balls of the same color. So the metal balls of the same color, it is red, it is blue, it is green. So we can see that we're going to take red and red. Well, that is the first R, and this is another R. Multiply them together. Plus, we are going to now take the blue and the blue, B and a B. So which is that? And the B there, multiply them together. Green and the green, we multiply them together. Then we are now going to say our probability is going to be 4 over 12, which is the R, B, then G, and a G. Then we're going to get a probability of R, B, or G, which is the metal balls of the same color, which is 19 over 66. That gives us 0.29. Now, grade 12, we have an activity here. And for this activity, grade 12, you are given 10 minutes to complete this activity. And your 10 minutes starts now. Welcome back, grade 12. Now let us focus our attention to activity number 1. Now activity 1 reads as follows. 5 blue balls, 3 purple balls, and 7 orange balls are placed in a bag. If 2 balls are selected without replacement, we need to start by drawing the tree diagram to list all the possible events. And remember, even if the question did not require you to draw that tree diagram first, you must start by drawing the tree diagram. Now, let us look at this one. We have blue. The blue balls are 5. Purple ones, there are 3. Then the orange ones are 7. Then the total is 15. Now, let us look at this one. So we are now looking at the blue one is 5 over the total is 15. Then the purple is going to be 3 over the total, which is 15. And for orange, it's going to be 7 over 15. Remember, if now I start with a B here, so B will change here. So on the blue one, it's going to change. It's going to be minus 1 on the blue one. Here, purple is going to be minus 1. Orange is going to be minus 1. How are we going to work this around? So for the blue one, so for BP, we are going to say from the 5 subtract 1, we are going to get 4. And it is without replacement. Then the total, if I chose the B or the blue one first on the first event, then the total will change to 14. Then this one affects only the blue one. So we're going to have 4 over 14. Then it's going to be 3 over 14, which is remaining as 3. The purple will now remain at orange as I pick the what? The blue one in the first event. If I choose the blue one in the first event, then the total will change to 14 and 14 because it is without replacement. Now on the second event, if I choose the purple one first, let's see what happens. Now if I choose the purple one first, then what's going to happen with the purple ones? The purple ones will now reduce to by minus 1 to 2. Then I take that purple one, I don't replace it back. Then what do I remain with? I remain with a total of 14 metal balls. Then we can now see that the blue one is going to be 5, as I've chosen the purple one in the second event, over the total of 14, because without replacement, and 7 over 14. Then the orange one, let's look at the orange one first. When I pick up the orange one first, what happens? From a total of 7 orange ones, I'm going to have a total of 6. And after I've taken that orange one, I don't replace it back. Then what is the total? My total will remain at what? My total will now remain at 14. So you can see after this branch, I take out that I go to the next event. Then the total is going to be 14, 14, and 14. And the total for the purple here, in this case, is still 3. And the total for the blue one, it is still 5 in that case. So this one is supposed to be 5 over 14. Right. Right, now, let's proceed. Now, let's say, determine the probability of selecting a blue ball first. Blue ball first, the one who start with the B. B, B, and B. All of these other ones, they don't start with the B. They start with the P, start with an O. So we are going to take this, multiply by that. That is the first one. Second one, those two, multiply them together. The third one, we multiply those together. So it's going to be probability of blue and any is going to be BB, is the first one, BP, and BO. So this is going to be what? It's going to be 5 over 15 multiplied by 4 over 14 plus 5 over 15 multiplied by 3 over. This is just simply just B and a B. The first B, which is this one, and the second B. The first B again, which is this one, and the P, which is that one of the P. Then the first B again, which is the B here, when multiplying with an O, with this O there. Right. Then we're going to get the probability of B in any as 0.33. Determine the probability of the second ball being purple. Second ball being purple, so we're looking at this part there. Second ball being purple. Right. So the probability of the second ball being purple, so we're looking for all of those that has purple as the second ball. So it's going to be what? It's going to be BP, PP, and OP. So we're going to take 5 multiplied by 3 over 14, 3 over 15 multiplied by 2 over 14. Then we're going to look at 7 over 15 multiplied by 3 over 14. Then the probability of N and P, it is 0.2. Now, point number 4, it says determine the probability of selecting 2 orange balls. So it's orange and orange. So it's going to be orange, and that orange, which is 7 over 15, multiplied by 6 over 14. So that is going to be 0.2. And for this homework, I will give you only 3 minutes to copy down this homework. Right. Now, this brings us to the end of our lesson. And for our next lesson, grade 12, we are now going to focus on the probability and quantum principles. So we are now going to work with the fundamental. We're going to apply the fundamental quantum principle to solve probability problems. So we are going to say, for our next lesson, we are going to use the techniques of fundamental quantum principles to solve problems where the events are not necessarily independent. Thank you. Enjoy the rest of your day.